Hello and welcome everyone. Welcome to lesson 3-2 Data IO Part 2. In this particular lesson, we will cover the advanced data input and output operations. Let's get started. In this particular lesson, we will be focusing on creating the CSV files and also reading the CSV files. Well, before we begin, we need to understand the meaning of CSV files. So it is an abbreviation of the comma separated values files, which is a text file where data is structured in records, and then the columns are separated by commas. So here, for example, here I have four different columns: the time steps, the X and Y and Z. I have the time steps X, Y, and Z. So each row corresponds to the record. So here, the first one is the column record, and then the second one is the first row, second row, and so on. So the columns are separated by the commas. So that's why we call it as the comma separated values file. And then each record contains one or more fields. The meaning of fields is here. So we have time steps X, Y, and Z. So those are the fields. And then the format's name comes from using the commas as the separator, as I mentioned before. So this is the reason why we call it as a CSV file. Now, I want to introduce you to Pandas data frame. A Pandas data frame consists of three key components. So the first one is the data, and then we have the rows and also the columns. Well, it is a two-dimensional data structure where data is stored in a tabular format, similar to the Excel spreadsheet. So now let's begin coding. So we create a data frame by using Python. First things first, we have to import the Pandas and NumPy random libraries, and then we generate a list of random three-dimensional points, and then we store them in a data frame before we save them as a CSV file. So we need this random NumPy random libraries in order to be able to generate the three-dimensional points. So let's dive into the code itself. So before we create a data frame, we have to import this pandas library, which is in the red line. And also we import the numpy.random library. So here I've simplified the name for pandas as PD and also numpy random as NPR. So we first prepare a two-dimensional Python list to store our data. So here we generate 10,000 numbers by three lists containing the random X, Y, and Z. So X, Y, and Z. So this particular list serves as the foundation of our data frame. So here, as you can see here, this is my two-dimensional list. And then the first element will be the X value. And then the next one is the Y value and the third value. So here I have used the NumPy random library. I've used the uniform function to generate random numbers from the uniform distribution. And then next, we create a pandas data frame from the generated two-dimensional list. So we specify the column names as X, Y, and Z. So this particular structure allows easy manipulation of data. To save the data frame as a CSV file, we just use the to_CSV functions. So here you can see this is the functions, and then this is the function where we get the current working directory. So for example, if you started your Python in your desktop, so it will get the full path to the desktop. And then what you do here is you just combine with the file name. So meaning to say the file here is on your desktop. Well, I'm just assuming that you are currently working from your desktop. So we specify the directory over here, and then it is the directory where the file should be saved. So ensuring that we can access it later. So once we have a CSV file, we can read it by using Pandas library. So we use the function read CSV, read_CSV function to load the data into the data frame, and then later it will allow us to process and analyze the data. So we can retrieve the data. If, for example, if you want to know some information from a specific cell of the data frame, you can always have a Python function to access that particular data. Well, when we read a CSV file, we store its contents in the data frame object. Since, well, yes, of course, you have gotten this information before, but again, I would like to reiterate that the new underscore data here is the data frame object. So we also specify the file's location to ensure correct loading of the data. So meaning to say, we extract the information from the fission_locations.csv, which is the CSV file that contains the data. And then I believe that the data is on the desktop, because I'm assuming that you are running your Python program from the desktops. I mean, this is not the general case, it's just my assumptions. But then we use this read_CSV function to extract the data, and then it will automatically convert the data into, it will fit the data into the data frame so that it can be easily read by Python. So here, the data frame object is stored in this particular variable. Well, of course, to extract a specific element from a data frame, we have to use the LOC function, or the locate function. So we specify the row index over here, and then we also need to specify the column name. So for example, the column name is X. So we want to access the desired value. So we want to know the value of X of the first row, the value of X of the first row in this particular example. You can always change to any other integer values here for the first argument, and the second argument should be the name of the column. Well, of course, sometimes we need to extract the entire columns as a NumPy array. We can also use this new_data, and then we use the square bracket. So inside the square bracket, we have to specify the column names. So it will extract all values in the X columns for this example. So the square brackets, again, I repeat, the square brackets are used for column selections. As easy as that. And then next, we can also apply some mathematical operations to the data frame columns. So for example, we compute the square root of the sum of assigned values for each x, y, and z coordinates. For instance, here we extract all values for the x columns, and then we compute the sine of these values, and then we compute the square of the sine. And then we do the same thing for the y column and also the z columns. And then we compute their row-to-row summations, and then we compute square root of the values that we have computed. So I believe you should be able to understand this idea, right? If you understand the vector operation in NumPy arrays. This is something similar to that. So if you are a bit confused with this, I suggest you to go back to the NumPy array lesson that we've done before, and then you try to understand the vectorized operation of NumPy array. So here are the takeaways that you need to take into considerations. So first things first, we use the read_CSV function to read and load data from a CSV file. The next, you have to remember that we use the data.location, or LOC. Then the first argument is the position in integer, and then you need to specify the column name. Well, you do this to access the data at a specific integer position, and also a column with the specified name. And then we use this particular syntax, data, and then in the square bracket, we specify the column names to extract the entire column with the name column_name. So I would like to stress that the column name should be a string.